Hi, I'm Mark from Split Second, and this video is an introduction to the R4 software. In this video, I'm going to cover how to install R4, create a file, connect to a unit, read data from ECU. I'll show you how to do some simple editing of table values, record live data, and manage files. The R4 software comes with the AIC1, PSC1, and FTC1 products from Split Second at no additional charge. The AIC1 family of products are additional injector controllers. These come in pressure or voltage versions, and the pressure versions could be absolute or gauge pressure. And in general, we use the AIC1 in two distinct ways. One for upstream injection, where we put one or two additional injectors on a spacer right beneath the throttle body. Or we use them for port injection, where there's a spacer plate on the intake manifold, and we have an additional injector per cylinder. So on the port injection, this is popular on direct injected engines, which are factory turbo engines like the BMW, Mazda, and Ford EcoBoost engines, and we can generate a lot of extra power with port injection on these engines. Now, the PSC1 programmable signal calibrators are used when we're not making huge power gains. We adjust mass airflow sensor and map sensor signals to fine-tune for more moderate kind of modifications, like a cold air intake or, say, a big bore throttle body, a cam, a header, free flow exhaust. These kinds of things can be optimized by fine-tuning signals and fine-tuning the fuel. The FTC ones are a combination of either an AIC1, PSC1, and a timing retard section. So these are used to fuel engines and boost that generally started out as naturally aspirated engines, and we added a turbo or supercharger. And the AIC1 or PSC1 is used to fuel the engine correctly. And then we also can do timing retard and in some cases fuel enrichment as well. And the FTC1 is popular for Toyota trucks and Jeeps. So with that, I'm going to demonstrate an install. So when you buy one of these products, you're going to get an R4 disk. And if you're unable to use the disk because your computer doesn't have a CD or DVD-ROM drive, we can provide a download to you. So if you get it as a download, you go to the File Explorer in Windows, and you find the download section under this PC. And the install file is called Setup. And to run it, just double-click it. That will launch the install wizard. And just follow the prompts. Just say next each time it appears and just use all the defaults. That will launch the install. When R4 is installed, it does not put a shortcut on your desktop. So if you'd like to do that, just put the pointer anywhere, as long as it's not over an icon. Right-click, go to New Shortcut, and we're going to browse to the area in the computer where we installed R4. So that's going to be this PC, local C drive, program files x86, and R4 controller. We select the R4 program simply called R4, say OK, next, and finish. And here is our shortcut. To run it, we double-click. It tells us it's version 1.5, which is the most recent version of R4. When R4 comes up, there's no options really available because you have to have a file open for R4 to do anything. So I'll click File. We create a file by clicking New Customer. Here it is. And we always want to make sure our files are located in this location on our hard drive. So the C drive, program files x86, R4 controller. So this will make everything run smoothly with R4. So we're creating a file. We'll make sure we're selected down here in this field for file name. I will type initial map, which is a good name when you're connecting to a box for the first time and just saving what's in it. So I've created a file. I'll click File, Open Customer. Select initial map, click Open, and now the name of the file appears at the top of the main screen. The first thing you always want to do when you open a new file the first time is click Options and System Settings and configure the file to work with the hardware you have. In this example, I'm going to connect on the test bench here with an AIC1A4, or pardon me, AIC1V4H, and so that's a voltage unit. The V in the suffix means it's voltage, so I'll select voltage. And it's an additional injector controller, so the default is fine. I'll close that with the X. And so with our file open, we're actually now ready to connect. So we'll normally be connecting with a USB to serial adapter cable. It's a really good idea to bring up the device manager on your computer before you plug it in, so you can kind of follow along and make sure the driver for your cable is installed correctly. Easy to do. Click on the Windows icon in the lower left corner. That allows you to start typing in the search bar, and you start typing Device Manager, DEV, and the option Device Manager comes right up. Click it, and these are all the devices connected to this computer. I have not plugged my cable in yet. I'll do so now. And I'm going to plug my cable in with the other end disconnected. So it's just the USB side for right now. You see PortsCom and LPT came right up. I double click it. There is the driver for my cable. It loaded perfectly and life is good. But sometimes things look a little different. For an example, here is what it looks like if it doesn't recognize the device and it doesn't load the driver. It comes up, instead of under PortsCom and LPT, it comes up under Other Devices, and it says USB 2.0, but what is it? I don't know. It's got a warning symbol. It didn't work. So if that happens to you, that line that appeared right there, you just put your pointer over it, right-click, and say Update Driver, and select Search Automatically for the driver. Click this. The computer will then go off and find the right driver and install it for you. And when it's done, it'll look more like this. And so life will be good. So we know it's COM5. We know what we need to know from the device manager. And that means over here, we're going to select COM5. So now, if you haven't plugged in the other end of the cable, great, you can plug it in now. But the key is plug in the USB side before it sees activity. Like once the AIC1 is turned on, it's going to start talking. And if it's talking when you plug in the cable, it could cause conflict in communication. So the graceful way to do this is plug in the USB side first, then either plug in the other side or power up. And so you can have the 9-pin serial side plugged in, but the ignition off on the car. So you plug in USB, then turn on the ignition. That's a really nice, graceful way to do it. So I am going to power up my device, and is the same thing as turning on the ignition on the car. And now I hit connect, and it connected. And I know it connected because the disconnect from ECU icon is now illuminated. So I go to Maps, Fuel Maps, and the icon to read data from ECU is here. And you want to be a little bit careful because the one right next to it is the Write Data to ECU icon. If you mistakenly click that, you're going to write this file and overwrite what's in your box. In this file, as I scroll back and forth, it's all zero. So you can see up at the top, the voltage scale is showing you I'm moving around. It's all zeros. If I write that, it's a disaster. So be sure to read data from ECU. Are you sure? Yes, and let it go. It's going to read maps A and B, and that'll be done. While it's doing that, I'd like to point out that I changed the settings in Windows to get this map table to render correctly. So what I mean by that is, let's say you bring up the map table and it looks more like this. And this is more commonly what you'll see on a modern laptop, and that's because screens today have much higher resolution and the table just doesn't render correctly. So if this happens to you, here's the fix. You go to the Start button and Settings and go to System, Display, and scroll down to Change the size of text. And you see I've got it set on 175. Now 125 is the default setting for Windows, and that's where everything looks normally like what you're used to. But what I've done here is I've selected 175, and that's how I got it to look like this. So that's how you can fix it. Now you can also change screen resolution, but I find that to be not not as useful because it tends to move your icons around when you go back to how you like it. It kind of messes things up a little worse than it does when you just change the font size. When you change back, things will look fine. So we now have read into this file what's in the box. And so let's say you received a kit from someone, and the AIC one is part of the kit, and it's supposed to be pre-programmed. And you want to make sure it is pre-programmed correctly. You can follow this procedure I just did, and you can either, say visually what is it supposed to look like, or check a value. Like you could say, hey, at 2.8 volts and 2,000 RPM should have a 2 in there. If you see a 2 there, well, it's probably the right file, and you can kind of eyeball. It's got real numbers. It's not all zeros, and it's not something wacky. So that's how you might look at this and verify it's the correct file. So I'd like to show you a couple of things about how to use the editing functions in the map table. And we use click and drag to select things. So we can select a range of columns, for example, or we could select a range of rows. Alternately, we could click and drag to highlight a region. And once we've highlighted something, we can now work with it. And one of the first things we can do is fill it with a value, like say 4, say OK. And the 4s here would mean 4 milliseconds. On an AIC1, the cell value is milliseconds. So that means every time we trigger an injection event, it will last 4 milliseconds long. Now, another thing the table is telling us is that and I'm just going to blow this up so we can see more of it. And let's say we put a bunch of 4s up and down throughout all the rows. And we can see that when we click a cell, there's a number presented in the upper left-hand corner, and it's saying 23.3%. That's the duty cycle. So when we're on a 4-stroke engine setting, which is what this is intended for, as we go higher and higher in RPM, we see, higher and higher duty cycles. That means that this fixed value of 4 millisecond pulses, as the engine spins faster and faster, well, those 4 millisecond pulses start to kind of run together closer and closer, and it makes it a higher and higher duty cycle. So that's what's going on with this. Now, I mentioned a 4-stroke setting, and let me point out that under engine settings, this is where you set it up for your engine. And of course, if this is a AIC1V4H, that means it's got 4 injectors for 4 cylinders. So 4-cylinder, 4-stroke kind of makes sense. And if it's for port injection, this is perfect. This means you're going to batch fire those 4 injectors twice per engine cycle. In other words, once per crank revolution. Works out great. But let's say we're doing upstream injection. And when we do upstream injection, we want to pulse at a fast enough rate to ensure that we get even fuel distribution. So for upstream injection, we're going to select 2-stroke. And what that does is it makes it so that we trigger injection on every incoming tach pulse. Now, if you go to 2-stroke, well, that throws off the RPM calculation. And to fix that, we cut the number of cylinders in half. So if we're doing upstream injection, we use 2-cylinder 2-stroke. And if you do that, and back at the map table screen, and you see a number here, well, we have to double that. So let's say it's saying 40% duty cycle with a 4. Because we're on the 2-stroke setting and we're pulsing on every tach pulse, it's really an 80% duty cycle now with a cell value of 4. So a couple other things about using using the icons to do tuning. Another really good one is change by. So if I click, I highlighted, say, this region here, and I want to change these numbers. Let's say it's too rich with values of 4, and I want to just knock everything down. I can say change by and say minus 25%. That means take away 25% fuel, and those 4s go to 3s. Another really cool thing is this icon, autofill. So let's say you fill in this with a value that works for your engine. It's amount of fuel that's right. Say it's 1.5 milliseconds. and you've got that set up, that's working. And let's say you move over to a higher pressure, you're tuning in this area, and the cell value that works there is a 3. So we'll put a 3 there. And then we don't want to go back and find the right tune for these intermediate values. We'd like to be able to get this map roughed in, quickly, and get closer to the final value. Well, I can just click and drag, highlight all the columns between these two, autofill, and there we go. It interpolates and fills in the values for us. So I've got, pretty much a scratch pad area I've been working in here. I want to clear it out. I can just click and drag, select all of them, and I can say fill selected. The default is 0. Say OK. I can back to 0. There's one more thing I'd like to show you here, and that is if you have corner values of say 1, 4, 3, and 2, and you click and drag to highlight those and autofill, it linearly interpolates all the values in between. And this is a real time saver for filling in, smoothing out a map, making it nice. And after you've kind of filled everything out, smooth it out, then you can go back and fine tune, go into individual areas. You might, click and drag a little area and say, oh, I need a little more fuel here. So change by, I'm just going to add, 3%. Okay. And it changes it just a tad, that sort of thing. So one other thing I'll mention is on the AIC family, AIC1, A4H, and G4H have 2 injector connectors that are driven off map table A and 2 driven off map table B. So if you have map table A and B different, well then the 2 sets of drivers or the 2 sets of injectors will have different numbers. But let's say we're using an AIC1 A4H for port injection, and we want all 4 injectors to be driven the same way. Well, we want the same values in both tables. So I can just get rid of these numbers here just to make things nice. And so let's say we've been working in table A and we got all these values, we like them, and we want to put those same values in table A. So all 4 injectors are operating the same way. Well, what I can do is highlight, and this is select all, highlights everything. And then I can do a copy. Then I go over to map B and paste, and that pastes in all the values from map table A. So here's what I did wrong, and I showed you how to not do it. Let me do it right. So I go back to A. I'm going to unselect all, and then I'm going to select all, and then I go to, and I got mixed up. I'm going to go copy, and then I'm going to map B. And the trick is go to the origin cell. So I got to get all the way to this cell, way up in that corner. Then I paste. And now unselect, so it's all nice and clear. My values in map B are the same as A. So I switch back and forth. They're on top of each other. There's no change. So this is a good thing to do with one of these A4H or G4H units to make sure the numbers are the same. Okay, enough about that. So I'm going to now show you how to view real-time data. So we go to real-time, all, and this is really good for making sure your installation is good. So RPM volts will show up here. So I can simulate a running engine here on the test bench, and I can turn on a signal generator and give it an equivalent RPM of 3,000. So let's say you start the engine, and okay, it's not going to idle that high, so we'll get on to idle. So let's say you're idling somewhere around 720. And you look at your dashboard, make sure the instrument panel is indicating 720. We're 720. Okay, perfect. It's a good install as far as the RPM goes. And then the other thing is I can turn on a generator for volts. And let's say we have a 2-bar map sensor, and we're just key on, engine off. So RPM goes to 0 because the engine's not running. But we turn the ignition on with engine off, and let's say we see a voltage of 2.3 or so, 3 or 4. That will tell you the barometric pressure reading of your map sensor is 2.3 volts, which is typical of a 3-bar map sensor. And so, or 2-bar map sensor. So if you are running a 2-bar map sensor and then you have a voltage unit that's hooked up to that signal wire, you should see something about like this with ignition on, engine off. If it's a 3-bar map sensor, it's going to be, more like 1.6. If it's a 2-bar map sensor, you'll see something more like 1.2. And these are the equivalent voltages of the barrel pressure reading. Okay, so to show you a little bit about real-time stuff, I'll turn the generator back on and we'll go up a little higher, and I'm going to make it go a little bit. And we're going to make it kind of move around. And I'm going to make the voltage kind of move around a little bit. And when we get up to high enough RPMs and pressures, we can get into the area of the map table where there's a bunch of numbers. And so we see the cell values changing as RPM and pressures changing. And so this is how we can monitor things in real time. And not only can we do that in real time, we can do a recording. So you click the start capture, and this data that's illustrated in front is being recorded to file. Then I stop the recording and I go to view recordings. They're stored under view recordings by time and date. And here's the recording we just did. So you can click anywhere and it'll tell you at that point in time, say this is in milliseconds, so that's 4.6 seconds into the data log. I had 3807 RPM, 3.7 volts. I had a 3.8 millisecond pulse of fuel and 24% duty cycle. So you can also see there's these other things, aux, A, B, C, D, and those you can use if you have the data acquisition option. Our standard products don't come with it, but you can special order products with the data acquisition option. And if you do so, you can set that up by going to Aux Input settings. Let's say you have an air-fuel ratio meter and you want to bring that in and data log it along with everything else. Well, you can set that up, say, as Aux Input A. We can rename it AFR. And let's say we have information from the AFR gauge manufacturer that tells us how the 0 to 5 volt analog output is set up. We go to our calculator, and let's say they tell us that with 0 volts, that equates to 10 to 1 air-fuel ratio, and at 5 volts, that equates to 20 to 1 air-fuel ratio. We calculate the correct coefficients to make that work, keep changes. Those coefficients are now loaded into the aux A section. And when we bring up real time, aux A is showing up. Move this. And it's now called AFR, and it's showing 10 to 1. I don't have an input for it, but there's 0 volts going in, and that equates to 10. So that's how you would set up an AFR gauge. Okay, so let's say somebody sends you a file, and you want to open that file in R4. So you're going to go File, Open Customer. Let's say it's your best buddy. He sent you a map, and you've got it on your computer. And let's see. Here we are. He sent you this map. You got to try this. Okay, all right, I'll try it. You find that, you open it, but this is under this PC and Documents. And remember, we said we like it to be in that other place. We want it to be in the R4 controller folder. So I'm just going to move it right here from here. I can do it right from this Open Customer field that was triggered by R4. I found the file, but I'm going to move it real quick before I click Open. So I just go to C drive, Program Files x86, R4 controller. There I am. I forgot to copy, didn't I? So let's go back. Documents. You got to try this. I'm going to copy. That's the trick. Copy. Then we go local disk, Program Files x86, R4 controller. Then I right-click and paste. So I made a copy, moved it to the R4 controller. The reason I did that is because R4 just works a lot more smoothly when it doesn't have to struggle with the path to find the file. So I put it in R4 controller. It's going to work great. So I open it, and I can connect. And I'm going to go to Maps and Fuel Maps. And here's this guy's really cool file. I still got my generators going. Let me just calm those down a little bit. and get rid of that. And we notice now we're seeing green and red. And the reason is anything in black means I'm less than 80% duty cycle. And so when it goes green, it's beyond 80%, between 80 and 100%. And then when it goes red, that means we've exceeded 80% duty cycle. So in fact, this great, you got to try this map isn't that great. This guy's an idiot. He's got up here, when you get to these higher voltages and higher RPMs, you use 325% duty cycle. That means the thing's just on, pouring fuel all the time. You have zero control. Once you get to about 85% duty cycle, you really don't have control. The thing's kind of sputtering to just being constant on. So you really, if you're working with AICs, you want to avoid these. Now, bear in mind, the color is based on that 4-stroke setting. So, be careful about that. And if you're in 2-stroke, remember you have to double that number up there. Okay, so that's all I'm going to say about that. One more little thing to cover about files. And that is, we gave you the example of when somebody sends you a file, find it on your computer, move it to R4 controller, open it from here. Works nice. Let's say you want to send somebody a file you created. Well, okay, fine. So we're, get out of here, close R4, get rid of it. And you can go to the Windows File Explorer. And let's say you go to, your hard drive, Program Files x86 and R4 controller, the place we always go. Hey, wait a minute. There's just that one sample file starting with Z. All the files we've been talking about aren't there. We created a file called initial map. We brought in this, you got to try this file from our friend. They're not here. So they're not here for you to grab and send to somebody else. Well, where are they? Well, the problem is R4, being an older program, is not Windows 10 certified. And the way Windows 10 treats these files, it puts them in a virtual store. And when you go into the application and run it, forget about it, I killed R4. So, here it is. When you run the thing, all you're really seeing here is a shortcut. These are shortcuts. They aren't really here. That's just a shortcut. So they're in the virtual store, and let's go find the virtual store. We'll go to the Windows File Explorer, and it turns out the virtual store is here. It's on the hard drive under Users, and I logged in under Anna's account, so I'm going to go to Anna, and you're going to go to App Data. Now, let's say you don't see App Data. It looks like this. It's not there. Well, what you got to do is you got to go over to View, Hidden Items, then App Data appears. They make it really hard to find. Local, you find the virtual store and Program Files x86, R4 controller. There are your files. So let's say you create a file. You want to share it with someone. This is where you find it. So I know I covered a lot of ground, but I hope it was informative. And with that, I will say that splitsec.com, our website, has lots of information that's quite useful. There's data sheets on the AIC1 and the R4 software. There's tech notes to follow along, and we hope that's helpful to you. I really appreciate your time, and thanks for watching.